with that whole fire alarm thing. YouTube, we just had a fire alarm. Nothing to be worried about. We're all safe. A little bit of burnage, but shout out from Jack Jellinger, YouTube Nation.
Shout out go to Gavin Palumka today. Very great guy. Love him dearly.
Wow, that's touching. I felt a tear of emotion within me, and you did as well. I'll give you an opportunity tomorrow to return the favor if you'd like. Okay, all right. All right, so we're just going to do question 7. It says, which of the following is a factor of both x squared minus 2x minus 3? So I'll write x squared minus 2x minus 3 and x squared minus 5x minus 6. So this is a question straight from the AccuPlacer. And what it wants us to do is to factor both these expressions. Maybe you remember that this factors to x times x. And then anybody know what I do from there? Okay, so the factors of the last number, 3 and -1 or -3 and +1. So Zelly, we're going to give you a chance again. The factors of the last number must add to the middle number. Excellent. So we choose -3 and +1. So in this situation, again, we have x and x, -6. A lot of times people are drawn to 2 and 3, right? But in this case, that won't work. It's a -6 and a +1. So x plus 1 is the factor that divides evenly into both of them, evenly into both. So our goal today is to review factoring. And if you flip it over, there's all sorts of different types of factoring, all sorts of different types. We're going to focus on these. Greatest common factor. We're going to focus on difference of two squares. And we're going to focus on trinomials. Okay? We've got other factoring techniques to get to, and we'll do those later on. But right now, we're going to focus on those 3. Those are what you remember the most. And so, factor the following using greatest common factor. What divides into both 10 and 18 evenly? So I take out the 2, and I answer the question, 2 times what is 10x? 5x minus 9. This is factored using a greatest common factor option. For number 2, what is the common factor between 12, 2, and 6? 2. And then they both share an x squared. So I factor out an x squared as well. 2 and x squared. 2x squared times what is 12x to the 4th? 6x squared. 2x squared times what is 2x cubed? X. And 2x squared times what is -6x squared? Exactly. What I'd like you to do is try example 3 and 4 on your own. For number 4, please make sure that you also factor out a negative. We say that when the lead term has a negative, you factor out a negative. Try 3 and 4 on your own real quick. Go. That's the greatest common factor option right there. 5 and 6, try those. This one, again, make sure you factor out a negative. Try 5 and 6. Example 5 should be 16x times 5y minus 3. And 6 should be -5d times d minus 3. This is like a question I have for somebody. Did anybody not take out a 16 and take out something else? What'd you take out? An 8. Let's watch and see what happens if you take out an 8, because I think that that's a very reasonable choice. Take out an 8x, and I get 10y minus 6. So what we can do is then we can also take out a 2. And so 2 times 8 would be 16 then. When you take out the 2, you'd be left with 5y minus 3. So you can still get to the final answer. It's just when you take out the 8, you should look and realize, oh, I can also take out a 2 on top of that. Okay? All right? Okay, sometimes we have trinomials. Now, just as you understand factoring, we'll give you an example here. What are 2 numbers that multiply to 33? 11 times 3. What are 2 numbers that multiply to 43? 1 and 43. It's prime, right? So sometimes there are composite numbers where you can take two numbers and multiply them together, but sometimes there's numbers that we call prime. Some trinomials are composite, meaning you can split them up into two factors, factors that are binomials, two parts to each one. X squared divides up into x times x, and then we already talked about this. I need two numbers that multiply to negative 15 but add to positive 2. Positive 5 and negative 3. Similarly, for example number 8, a lot of times people see this, and when they see 6 and 5, they think of 2 and 3 right away. But that doesn't work. I need two numbers that multiply to 5 that add to 6. Positive 5 and positive 1. Now, I apologize, folks, that my formatting is kind of messed up here. You see it says example 10 and then dot. There should be a space here, okay? What I'd like you to do is do 9, 10, 11, and 12. Factor 9, 10, 11, and 12. And then we're going to get to our last factoring, which is the difference of two squares. Go ahead. Okay, as we look at 9, 10, 11, and 12, should have x minus 3 times x minus 4. For 10, x minus 4 times x minus 8. If you look at 11, the two numbers that multiply 64 that add to 16, it's 8 and 8. So do you know how else we can write that? Squared. So this would be x minus 1 squared. Okay, we also have the difference of squares. And I apologize, again, it kind of runs together, but x squared minus 1. It kind of looks like this. X squared plus 0x minus 1. I know that may seem silly to look at it that way, but we factored to x times x, and what we need is two numbers that multiply to negative 1 that add to 0. Yeah, so sometimes people may have wondered, well, why is this always plus or minus 1 or plus minus 2? Well, because it has to add to 0 in the middle. That's why. So x squared minus 9, how is that going to factor? X plus 3, x minus 3. How about x squared minus 196? What are the two numbers that multiply to 196? Ooh, Smith. Yeah, very good. Plus 14, minus 14. This is 4x squared minus 81. Little trickier. What are the two things that multiply to 4x squared? 2x, 2x. Two numbers that multiply to negative 81. Hundred x to the fourth minus 36. What do you multiply by itself to get 100x to the fourth? 10x squared plus 6 minus 6 for the 36. And finally, the last one, x squared y squared minus 4. What do you multiply by itself to get x squared y squared? xy, xy, plus 2 minus 2. Okay, flip it over as we, I'm going to do two problems with you, and then you're going to do some work together on this. Yeah, I'm sorry about that. Again, they kind of run together. We got 2x squared plus 10x plus 12. And 3x squared minus 75. So, folks, here's a chance to kind of see where you're at, investigate a little, play around. This is factoring completely. So now we're not saying factor trinomial. We're not saying greatest common factor. We're not saying difference of two squares. But we always start, every time it says factor, we always start with greatest common factor. Always start there. What can you take out of both of these, or all these? Take out 2, and you're left with x squared plus 5x plus 6. The question is now, does x squared plus 5x plus 6 factor? That factors like a trinomial on the last page. So I have x and x, two numbers that multiply to 6 and add 5, 2 and 3. Now I'm done. So you can see it's factoring more than once. 3x squared minus 75, what can you factor out of both there? And I'm left with x squared minus 25. X squared minus 25 is not a trinomial. It's a difference of 2 squares. We remember how that factors. That was our favorite one. We had an x and an x plus 5 minus 5. You don't have to do 24, but what I want you to do right now is spend some time, look at 21, 22, 23, 25, 26, 27. When you get one of them done, please put the answer up here on the board. So, Campbell, you're already done with at least one of those, right? So if you could take one of those and put it on the board, don't put all of them. But as you finish one up, put it up on the board so we can see and check our answers to see if we're getting a